Hello and welcome to this new section on scenario analysis and stress testing in this course, AI for Risk Management and Compliance Excellence, and the first lecture of this section. So in this section, we will give you some good idea about how can you use AI for excellence in scenario analysis and stress testing. And we will begin by taking a look at this technique called AI enhanced Monte Carlo simulations. So how do you think you can use AI-enhanced Monte Carlo simulations to simulate various adverse scenarios and estimate their potential impact more efficiently? Any thoughts on that? Using AI-enhanced Monte Carlo simulation allows organizations to simulate adverse risk scenarios with far greater speed, realism and precision than the traditional methods. Now, how does that happen? AI improves the input modeling, adaptive sampling, and interpretation of the simulation outputs. And that makes it easier to forecast financial, operational, and compliance related risks under uncertainty. So that's how, at a snapshot, AI enhanced Monte Carlo simulations, uh, help you identify various adverse scenarios more efficiently. Now, what are Monte Carlo simulations? So, Monte Carlo simulations, as you see here, simulate and estimate the probability of different outcomes by running thousands or millions of simulations using randomly generated variables based on historical or assumed distribution. And as you see here, there are four steps in this. There is observation, there are distributions that you decide, then you do simulation based on data, and then you quantify the outcomes. So that's what a Monte Carlo simulation is. Now, how does AI enhance Monte Carlo simulations? Let's take a look at compare it to the traditional Monte Carlo simulations and see how does that happen. Now, in traditional one, you use a static probabilities distribution, whereas AI enhanced Monte Carlo, it learns input distribution dynamically from the data. So it's dynamic in nature versus static in traditional Monte Carlo. Then in the traditional Monte Carlo, you use uniform sampling, and in AI enhanced Monte Carlo, the AI focuses on high impact or rare scenarios. There is linearity and simplified assumptions in traditional Monte Carlo, whereas in AI enhanced Monte Carlo, the AI captures non-linear and hidden relationships, which are difficult to detect. Then in traditional Monte Carlo simulations, you have interpretations that is to be done manually, whereas in AI enhanced one, you have that AI doing that automatically in terms of pattern recognition in the outputs. So that's how AI enhances the Monte Carlo simulations. Now let's take a look at some use cases of AI enhanced Monte Carlo simulations in risk management. In the financial risk area, the adverse scenario that are simulated are like interest rate spikes and credit defaults. In operational area, you can do the simulations for supply chain breakdowns and cyber attack impact. In compliance area, you can do simulate regulatory penalties due to non-compliance. And for ESG risk, you can look at climate disruptions, reputational fallout from controversies, etc., etc. Now let's take a look at the steps that you can take to use AI-enhanced Monte Carlo simulations. So first step would be to define the key variables and the outcomes. Variables and the outcomes. And what are these variables and the outcomes? In terms of the drivers, you have input prices, demand volatility, failure rates, and external shocks as examples. And in outcomes, you could have things like revenue loss, operational downtime, legal fines, and market share drop. But you could define them the way you want. You need to define what outcomes do you want to simulate and accordingly pick the drivers. Then you need to use AI to model input distributions more accurately. And it's And that you need to do instead of assuming fixed distribution like normal or uniform. You can use, you know, techniques like machine learning regression and to model relationship between input variables. You can use generative models to generate synthetic but realistic input scenarios. You can also use Bayesian networks to model conditional dependency between variables. And also, a time series forecasting using LSTM or Profit could be done where you can predict future values with uncertainty bounds. Now, let's take a look at example of this. Now, using an LSTM model to forecast demand volatility. For that, you need to feed into simulation as a variable, right? So so these are that's one example of using LSTM model for uh, you know AI driven Monte Carlo simulation. Then you need to then you are ready to simulate thousands of scenarios using enhanced sampling. There you can use AI based samplings like importance sampling where you focus more simulation on high risk area. You can also use active learning where AI identifies informative scenarios to explore instead of doing any Tom, Dick, and Harry. And then there are surrogate models where AI approximates expensive simulations quickly. And the result is that simulations are faster and focus on what really matters rather than working on that what is not likely to happen. Then you analyze simulation outputs with AI, and there are many techniques that you can use. You can use clustering to group similar outcomes for better understanding. You can use anomaly detection to spot rare but catastrophic scenarios like COVID-19. And you can use Shapley distribution or feature attribution to understand what drives high risk outcomes. So, like this, you can analyze simulation outputs with AI. So next thing is to know that you can identify and quantify these adverse impact scenario. And an example of that would be to say that there is a 12% chance of revenue drop exceeding 12, 15, $50 million due to combination of FX fluctuation, late shipments, and negative PR. So like this, AI helps surface few important things like black swan event, uh, which is a highly unlikely to happening event, but would have severe consequences if it did happen, like COVID-19. Then you can also do scenario narrative, the cause effect chains as you see here, and also identify risk concentration zones where the risk is most likely to happen. So like this, you can identify and quantify the adverse impact scenarios. Right. Then AI also helps you visualize and interpret results for stakeholders. You can create outputs like probability distribution curves of the outcomes, value at risk or conditional value at risk charts, tornado charts showing the key drivers of the output simulation, and stress testing dashboards that can answer the questions like what happens if X and Y and Z go wrong altogether. So it can show you all that. And the tools that you can use for dashboarding are things like Power BI, Tableau, Python Dash, and Streamlit. What are the tool stack that you can use to build AI enhanced Monte Carlo models? So for the ML layer for input modeling, you can use scikit-learn, XGBoost, PM, PyMC3, TensorFlow, and Profit. For simulation engine, you can use NumPy, SymPy, Pyro, Simul 8, at risk, and Crystal Ball. And for enhanced sampling in surrogates, you can use GPyTorch, BOTorch, Bayesian optimization. And for visualizing, you can use Matplotlib, Plotly, Dash, and Power BI. So these are various tools and frameworks by the layer that you need to use. Let's take a look at an example of simulating cyber attack impact. You know, so you begin by looking at the attack frequency, and there you can use the method of time series of historical breaches. Then you discover the cost per incident, which can be modeled using generative adversarial network GANs. And then you estimate or simulate the impact on operations where with using ML that can predict downtime based on the system dependencies. And then you generate the simulation output, which says that 500 plus 500,000 plus 5,000 plus attack scenarios uh, would lead to distribution of the total losses. And then you get an AI output which found that 9% chance of greater than $10 million loss within 6 months. So that's an example of simulating cyber attack impact. So what are the benefits of AI enhanced Monte Carlo simulations? First, it does more accurate risk modeling, and that leads to inputs reflecting real world complexity. Then also it is faster and more accurate in terms of its simulations, and this helps AI reduce compute costs by targeting rare events. Also, there is greater transparency, which helps you understand drivers of bad outcomes, the key variables, leading to better decision making that supports risk-based capital allocation and planning. And you can also do scenario-based storytelling to communicate complex risks clearly to the executive. So these are some benefits of AI-enhanced Monte Carlo simulations. So what do we do next? So in the next, we will look at another aspect, another way to look at scenario analysis and stress testing, and there we will see how can you use generative AIs to for scenario generation and do this simulations, right? So that's what we will do in the next lecture. So thank you so much for watching this first lecture on scenario analysis and stress testing. I hope you're continuing to learn new things, continuing to enjoy, and I do look forward to see you again in the next lecture. Please feel free to message me if you have any questions. I'll be happy to answer your questions, and do download the PDF file to take a look at anything that you need to.